My name is Karara Buharo, and I'm a professor of chemistry. And today I have a project called The Mechanism of the Dual Nature of the Coronavirus, which is designed to unveil or reveal how the coronavirus becomes the world pandemic, how the coronavirus triggers the world pandemic by infecting a specific region inside the body. And this objective for this mechanism of the dual nature of the coronavirus is to find exactly or investigate exactly which region is infected, what area in the body is infected. The respiratory system is the one that's infected by the coronavirus, but there's a specific site, the alveoli of the lungs, where gases compound, oxygen and carbon dioxide are exchanged, and this is where we're going to be focusing on. But first, we're going to look at the mechanism of the interaction between carbonic anhydrase and hemoglobin, the two machinery compounds or molecules that help regulate the binding of oxygen and transfer of that oxygen to the tissues. Carbonic anhydrase here contains a zinc ion. Zinc facilitates the abstraction or removal of a proton from a water molecule that's bound to the active site of carbonic anhydrase. This proton results in hydroxide generation. When hydroxide is produced, the hemoglobin binds oxygen first by binding one molecule of oxygen, and as the acidity increases because of the hydroxide, more oxygen is bound to hemoglobin. All this is regulated by carbonic anhydrase. In the tissues, carbon dioxide is produced, but carbon dioxide is not soluble in water. It must be converted to bicarbonate, which is carbonic acid. It happens like this. Carbon dioxide binds to the active site of carbonic anhydrase, and the hydroxide reacts with carbon dioxide to generate bicarbonate, which is carbonic acid. And now that can be transported into the bloodstream. In the bloodstream, the carbonic anhydrase results in this carbonic acid produced. That's why we call this an enzyme, which speeds up the rate of chemical reactions. The carbonic acid lowers the acidity or the pH of the lungs, and this results in removing carbon dioxide, normal binding of oxygen in the tissues, but just dissociation. In the presence of the coronavirus, this mechanism, which requires water to begin the process, is reversed. When this process is reversed, this mechanism is reversed, the coronavirus accelerates exponentially generation of more carbonic acid from carbon dioxide. This change in chemistry of the lungs is the cause for the world pandemic. And I want to look at a photograph. This photograph here, see this photograph, which looks like a mechanism by itself, it looks more like a chemical reaction, is actually the effect of the coronavirus. Normal lungs look like this. They are shiny, they have color, which is burgundy, and when infected with the coronavirus, which acts as a catalyst, the result is inflammation. The lungs are blackened, they are no longer functioning to transport oxygen with the hemoglobin to the tissues. So oxygen is no longer transported with the infected lungs because of the coronavirus. Looks like a mechanism, a chemical reaction, because it's from a chemist's point of view. So in the presence of the coronavirus, there's an increase in carbon dioxide in the lungs, which increases the concentration of carbonic acid, and this decreases the pH or acid level. This is the cause for the inflammation, because it's like burned lungs because of acid. Although that's a weak acid, through the concentration and also the increase in carbon dioxide causes this chemistry to change, which causes the pandemic, the world pandemic. And just want to point out one more time the alveoli of the lungs, the alveoli of the lungs. This is the right lung, left lung, alveoli of the lungs. This is where this process or this infection is happening, and is specifically at the carbonic anhydrase active site. And the result is we have more than 4 million people infected in the United States, more than 16 million infected around the world. US deaths more than 150,000, and worldwide 680,000 people who have died because of the coronavirus. So in conclusion, my name is Karara Mohoro. I'm a professor of chemistry. The mechanism of the dual nature of the coronavirus does what it's supposed to do, unveil how the interaction between carbonic anhydrase and hemoglobin occurs to sustain life. But in the presence of the coronavirus, this mechanism is disrupted or corrupted exponentially to destroy the alveoli of the lungs. The changing chemistry of the mechanism of carbonic anhydrase, that interaction between the two molecules, is the cause for the world pandemic. Thank you.